Okay, today we're going to look at a little more information about using equations to solve problems. So what we need to do is look at how these are different from the ones we've done earlier in the unit. We are going to try to use equations here using algebra. The difference is these problems show a comparison of two situations. So this is different from the ones we have done earlier where we just had one story, we knew where we wanted to end up. These are a little different. So you notice we're using the questions to find when the two plans cost the same. When the two plans cost the same. We are trying to, again, on this one, example 2, we are looking for when is the cost of the two plans the same. And here, how many bears must we sell for the cost to equal their, and this word expenses should actually be sales. When will two situations be equal to each other? So the question is a little bit different on these. So when we're looking at two situations, then a highlighter is helpful here so that we can identify those two situations. So that's what holds these two, or these problems together, is that all of them involve solving two things. So here we're comparing Plan A and Plan B. All right, and then we go on a hunt. Which of this information goes with Plan A? Well, it's right behind it. Plan A charges $24.95 per month plus 10 cents per minute. Okay. Plan B, on the other hand, charges $19.95 per month and 20 cents per minute. So that we can have a constant in this one, we're going to find when are the two plans the same for 1 month. So we're just going to look at this for 1 month. So if I'm planning this out, we're going to make a table like we have for the other problems. But here, because we have two situations that we have to observe, we have to make two tables. Okay? Using the questions to find when the two plans cost the same. So what I have to determine is, what am I comparing? I'm comparing their costs. The difference is I don't know what cost I'm headed for. I just want the two costs to be equal. And I know that the cost of Plan A depends on the monthly payment and a payment for the minutes. And so does this one. It plans for the monthly and the minutes. Okay? So what I have to do here is determine which of these is the variable cost. If I set it up for 1 month, then that means that monthly fee I'm just going to pay one time. So that becomes the constant in this problem, $24.95. And then if I am trying to figure the cost, I have to know how many minutes that I am going to talk. That's what's going to have an impact on the cost. So like in science, the cost depends on how many minutes that I talk. So up here we notice that it's 10 cents per minute. So that means 1 minute is going to cost me 10 cents, or 10 times 1. And then if I buy 2 minutes, that's going to be 10 cents times 2 plus the $24.95 monthly fee and 10 cents times 3. And then we realize we can change that into a algebraic expression by looking at what is constant, the $24.95, and where is the changing number. It is behind the 10. So that is an expression that describes the cost of the Plan A for the first 3 minutes. All right? And this one would be $25.05. This would be $25.15, and this is $25.25. Okay, so now we're going to look at the other plan. Again, we're going to compare them the same way. We just have different numbers here. Again, because we're doing 1 month, This $19.95 is paid one time, so that is our constant. And just like the other one, our 20 cents is what's, we don't know how many times we're paying that, so we're just guessing. So here, this would be $19.95 plus 20 times 1 minute. And again, very similar to the last one. And $19.95 plus 20 times 3 minutes. Okay, so this particular cost then is $20.15, and this is $20.35, and this is $20.55. Notice this is increasing by 20 cents each time, and this is increasing by 10 cents each time. So if I wanted to change this into an expression with a variable in it, then I would take the constant that stays the same. I only pay that one time. And then the 20 cents, I'm trying to determine how many times I have to pay that. So then, if I'm going up here to look at the equation, or the question, to get my equation, when are the two plans costing the same? That means my equal sign goes here. When is plan A equal to plan B? So then we solve that. That's why we had to learn how to solve a different kind of equation with variables on both sides before we could talk about these word problems. Okay. And here, remember that process is we're going to do opposite operations because we're combining things that are on opposite sides of the equal sign. Again, I'm going to use the strategy here that I'm going to make the smaller of the variable terms disappear. Notice that I'm subtracting 0.10x, not just 0.10, to make that disappear, leaving me with $24.95 on this side, $19.95 plus 0.10x. And with money, you got to be very careful with your decimal points and make sure that you don't leave them out, or else it means something totally different. This, without a decimal point, would mean you're paying $10 a minute. So it is important not to lose that decimal point there, or any of these in the money problem. Then remember, we clear the constant, which in this case is the $19.95. I need to subtract that from both sides. So there's another disappearing number, which is what we want. And then I've got my coefficient. I'm going to divide to get rid of my coefficient, to get rid of the multiplication that's occurring, and x is equal to 50. 50 minutes. So what that means is at 50 minutes, then, these two plans will cost the same amount. And to check that, I could plug that back into my equation here and show you that plan A would be $24.95 plus 0.10 times 50. So this would be $5 plus $24.95. That's $29.95. And then plan B, if I check that out, that would be $19.95 plus 20 cents times 50 minutes. That's $10 plus $19.95. So this allows me to see that both plans would cost me $29.95 if I talked for 50 minutes. So this is what we call the turning point in the situation. Earlier than 50 minutes, if I don't talk 50 minutes, if I talk less than that, then that means this plan that starts off cheaper is going to be the cheaper one. But actually over here, this is the one that starts off cheaper. It only has a $19.95 starting point, where this one starts at $24.95. But this tells me at 50 minutes after that time, then the other plan that starts off being more expensive, notice at first up here in the table. Okay, I'm looking at the tables here now. I notice this one starts off being cheaper, but at 50 minutes, if I took the table out that far, I would see them be equal. And then after that, this one that starts off being more expensive would actually be cheaper after 50 minutes. So that's why this number is so important. It lets us make decisions about which plan we need to take depending on how many minutes we think we're going to talk. All right. So tables aren't necessary. They're just a tool to help us write equations. Again, here, we're comparing two things. Green's Gym, and they are $50, a one-time fee of $50, and $30 per session. And then we're comparing that to a new fitness center, which they have a fee of $250.10 for each, or $10 for each session. So again, I'm looking to see when these two plans cost the same. So I'm comparing two situations here. Let me zoom in a little bit. All right. So here we've got numbers here, two numbers that go with each story. And again, the general idea here is usually there's a number that stays constant and there's a number that changes, or we don't know how many times that we're going to pay that. So right here, if I look at Green's Gym and I look at the new gym and I'm trying to find out when they're equal, Green's Gym, I have to pay a fee and I have to pay for sessions. So the fee is the one I'm paying one time. The sessions is the one I don't know how many times I'm paying. So that's where my question mark is here. All right. So I can fill in my $50 one-time fee, and then they are $30 for each session. So notice here, how many sessions is my question, and this is the number in this situation that has to do with sessions. So that's another hint, a way to look for where your letter goes, or which number your letter goes with. So the same thing over here. The new club also has a fee, and they also charge for sessions. And again, that's what we're looking for. We don't know how many sessions we're going to do. We know we're going to pay the $250 fee. That's a lot bigger than the $50 we paid here. But their sessions are a lot cheaper, 10x. And we want to know when those are equal. Okay. So then we would solve that. Again, I'm going to this time go after the 10x. And I'll go after the smaller one. All that does, it keeps me from having to deal with negative numbers. Okay, so I have solved this equation. I subtracted 10x from both sides. Then I cleared the constant by subtracting 50. I divided both sides by 20 to get rid of the coefficient, giving me a solution of 10 sessions. So that allows us to see that at 10 sessions, it doesn't matter which company you go to, it would be the same price. Okay. Then another situation where we need to compare is in the business world. And in the business world, we have two main factors. We have the money we pay out and the money that we are taking in. So, in other words, we have costs and sales. And in business, there's something called a break-even point. And that occurs when costs are equal to sales. So when the money going out is your cost equals the money coming in, your sales, what that means is you have zero balance. You aren't in the hole, you aren't losing money, but you also haven't earned any money. You've made enough money to pay your bills, basically. So when we compare these two situations and look for that break-even amount, we have to identify our costs. So this is a simpler business situation. We have costs of $8 to make each bear and $1,500 to run the machinery. Okay, and then we have our sales, and that is we're going to sell the bears for $12 each. Notice here my question is how many bears. So I notice where the bear, what number the bear ends up being connected to. All right, and that's going to help me determine where my letter goes. So right here, if I look at my costs, I know that my $8 and my $1,500 are the numbers associated with the cost. So now what I've got to decide is this a constant or a coefficient? And because it has to do with bears, and we don't know how many bears, that is the question, that's where my letter goes. The $1,500 is a one-time fee that I pay for the machinery. And then my sales over here, again, have to do with the number 12. So I have to decide, are my sales $12 one time, or does that $12 occur more than once? And in this case, I hope it occurs more than once. We don't know, again, how many bears we have to sell. That's what we're trying to figure out. So, again, we're going to subtract the 8x. I'm going after the small one to prevent us from having negative numbers. It's okay to do either way. Notice this one doesn't have a constant. We only have a coefficient. So I'm going to divide off the 4. And that equals 375 bears. So understand the meaning of this. That means if I sell 375 bears, let me show all that. So I subtracted the 8x, I've divided by 4. If I sell 375 bears, I've only made enough to pay for my bills. So I haven't actually made any money until I sell more than 375 bears. So